Okay, how's it going, guys? I just wanted to take you through how to graph the secant of x, which we did today in class a little bit. But I wanted you to have a video of it so that you could apply that to graph the cosecant of x, which is a really similar process. So the first thing is the definition of the secant of x is that it's the reciprocal of the cosine function. So if you take all the values of cosine and you put them over 1, then you get the secant values. So another way to rewrite the secant of x is as 1 over the cosine of x. Another thing I want to point out is that I'm assuming that you're comfortable making a sketch of the graph of cosine and you're comfortable making a sketch of a cycle of sine of x. So if you want a refresher on those, stop this video and go look at my other video of how to make a cycle of sine and cosine. Okay, so because the secant of x is so heavily influenced by the graph of cosine, we always start by just I always make it a dotted line sketch of cosine of x. So that hits 0 at pi over 2, and then at pi we hit -1. At 3 pi over 2, cosine passes through 0, and at 2 pi it goes back to 1. And you're going to see why we do this, because we're going to refer to this to help reason our way through the graph of secant of x. So the first thing I notice is, what I want to see is, well, where does this cosine graph hit 0? I notice it hits 0 at pi over 2 and at 3 pi over 2. Why do I care? Because if I think about this, if the value of cosine is 0, then its reciprocal is 1 over 0, which is undefined. And 9 times out of 10 in calculus, if you get a number, like other than 0, if you get any value over 0, what that's going to give you is a vertical asymptote in the graph. So at pi over 2, we have a vertical asymptote. So I'm just going to sketch that with a dotted line. And at 3 pi over 2, I have a vertical asymptote. Okay? Now the next thing is, I notice that cosine hits 1 at the x value of 0. We hit 1. And also at 2 pi, we hit 1. And I just want to think about, okay, so the reciprocal of 1 is 1 over 1, which is 1. So therefore, the secant value at 0 and 2 pi is 1. Similarly, at pi, we notice that cosine is -1, and if I'm just thinking out loud, 1 over -1, which is its reciprocal, is -1. So the secant is -1 at pi. So it has the same values of cosine at 0, pi, and 2 pi. Now the next piece of this is, I need to notice something. I need to notice that as cosine approaches pi over 2 from the left side of it, so as you follow your eyes, as we're going from here towards pi over 2, notice how the value of cosine is positive and it's approaching, it's getting closer and closer to 0. Now think about what happens if I were to take the reciprocal of that. If I do 1 divided by a number getting closer to 0. So if I take 1 divided by 0.5, I get a larger value. And if I divide by an even smaller value, like 0.1, I get an even larger value. Well, if I divide by a number, and that number is getting closer and closer to 0, like if I divide by 0.001, I get 1,000. If I never actually get to 0, I just keep dividing by a number that's really close to 0, then your function is going to get really, really larger and larger and larger. So if you think about it, we start at 1 and we get really larger, 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 but we never touch our asymptote. So the graph of secant approaches infinity as x approaches pi over 2. Now what happens is I approach pi over 2 from the other side of it. I approach pi over 2 from the right of it. Well, now my y values, they're still approaching 0, but this time they're negative. So just think about it. If I divide by a negative number, getting close to 0, well, then I'm just going to get a very large negative number. I don't like saying that, but it makes sense. I get a very, very negative number. So if I divide by negative 0.5, well, now I have negative 2. If I divide 1 by negative 0.1, I get negative 10. So if we just reason through this, now I'm thinking that, at pi, we know that secant is defined at negative 1. And then as we get closer to pi over 2 from the right of it, I'm just getting a very, very large negative value. And just to refresh, we know what happens at pi over 2. We know that this function's not defined because there's an asymptote there. Similar reasoning will get us to what happens at the next asymptote. We notice cosine's approaching 0 on the left side of 3 pi over 2, and it's negative. So I'm dividing 1 by a very small negative value. It's going to get very large and negative. On the right side of 3 pi over 2, we know that cosine is approaching 0 and it's positive. We've already defined it up here at 1, so then we know as we travel to the left, it's just going to get very large and positive. And then this pattern actually repeats forever. But this is one cycle of secant of x. So this is y equals secant of x. I hope this was helpful. I had to take like 15 takes, so I hope it was helpful. Now how do I stop it? There we go.